Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So I'm going to talk about how to find the area of a sector, okay? Please review previous videos and ensure you understood it. Actually, where we talked about the arc, how to find the circumference, what's the concept of the radius and stuff like that. Before I proceed, don't forget to like, share, and subscribe. And if you have any question, don't hesitate to contact me. And also, if you've not clicked the notification bell, please do so that when I post new videos, you'll be the first person to know. All right, so the area of a sector basically is the space inside the section of a circle created by two radii and an arc. All right, so basically, what I'm saying is that the area of a, no, not this one. So if you have the shape, so you have a circle here, okay? So you're gonna have two radii, okay? So we have two radii like this, okay? So like this is the radii, this is a radius, and this is a radius. Both are called radii plural. And also this is the arc. So I've talked about the minor arc and I've talked about the major arc in the previous video. So now the area of a sector is the space inside this part here, all right? So this space here is what we are looking for, is what we call the area of a sector, all right? So, and basically the area of a sector is a fraction of the area of a circle. So, because I know students do take notes from what I've said, I do say here, so I'm going to write it down. So the area of a sector is the space inside the section of a circle created by two radii and an arc, okay? So that's the area of a sector. And basically, like you can see, the area of a sector is going to be a fraction of the area of the entire circle. So I'm going to talk about how to find the area of a circle later, but this is going to be a fraction, all right? So from this diagram, you can see it is a fraction of the area of the entire circle. Okay, now if you look at this carefully, all right, we can still break down the circle into two forms, okay? If you look at this carefully, you can break it down into two forms. So you can see that you have, there's a sector that looks like this. The smaller one, you're gonna see the smaller one here. Then you will see the second one. If you separate this, it will have something that looks like something like this. Are you seeing? So that means we can break this down into two, all right? So that means the sector, so you're gonna have one that looks this way and one that looks that way. And the angle for this one, so this is the angle here, all right? So we'll call this, let's call this θ1 for this one. And the angle is the other angle that we have here. So that means this is the θ1, and this is gonna be the θ2, all right? And this is the angle here. So that means technically, at the end of the day, we have two sector, all right? Now, this by the left is what we call the minor sector. And the one by the right is what we call the major sector. Okay, so by the one by the right is called the minor sector, and the one by the left is called the major sector. Now, if you look at this more carefully as well, so that means I can break down the types of sector into two. So that means we have the types of sector. So from what we can see here, the types of sector, we have the minor sector, and we have the what? The major sector. The minor sector and the major what? Sector. Now, the difference is basically the difference between the minor and the major is basically in terms of the angle. So the angle here is the angle sustained by the minor sector, while this angle here is the angle sustained by the major sector. So what is a minor sector? A minor sector has a central angle which is less than 180. So a minor sector has a central angle which is less than 180. Okay? Now, but this is different from a major sector. A major sector has the central angle which is more than 180. Okay, so a major sector has a central angle which is more than. Okay, so when the central angle is less than 180, okay, it's a minor sector. When the central angle is more than 180, it's a major sector. So the formula for this, okay? So this therefore leads us to the formula, okay? So therefore, the formula for the area of a sector, like I said, is a fraction of the area of a circle. So the area of a sector is equal to theta divided by 360 multiplied by the area of a circle. So pi r squared. Okay? So theta over 360 multiplied by what? Pi r squared. So this is how you find the area of a what? Area of a sector. So as we all know already, okay, where theta is equal to the angle of the sector and when r is equal to the radius of the circle. So that is that for that. So you can see here, so a circle, a sector is sustained by two radii and an arc. You have two sectors. You have a minor sector and you have a major sector. And the minor sector has the central angle is less than 180, while the major sector has a central angle which is more than 180. And the area of a sector is theta over 360 times pi r squared, where theta is the angle of the sector, and r is equal to the radius of the circle. So we'll go to the next part now. What are the 3 steps to solve this? So the 3 steps are the 3 rules, okay? The 3 steps are the 3 rules. So the first thing you have to do is to find the length of the radius and also the size of the angle creating the sector. So you have to keep in mind here, if you're looking for a minor sector, that means you have to look for the smaller theta, the one that's less than 180. But if you're looking for the major sector, the theta you have to be looking out for has to be the bigger one, the one that is greater than 180. All right. So the first thing we'll do here is to find the length of the radius okay, R, and size of the angle creating the sector. Okay, so you have to find the length of the radius and the size of the angle. When we talk about the size of the angle, I'm referring to theta, okay? So I'm referring to theta here. So the size of the angle theta creating the sector. Then number two, when you're done doing that, the next thing you have to substitute it appropriately into the formula. You know the formula is theta over 360 times pi r squared, right? So the next thing you have to do is that you have to then substitute appropriately into the formula. Then the area of a sector will be equal to theta over 360 times pi r squared. Okay, so we already know the theta, we know the radius from the question, and you can get that. And when you're done with that, number three, what you do then, you then what? Simplify. Okay, so that's how you do. You find the length of the radius and the size of the angle creating the sector. All right, so what I'm going to do, we're going to go and solve some questions now. All right, so I'm going to pick some example now so that we can solve. All right, so let's go. The first one I have here, so for example, number one, we're told to find, okay, find the area of a sector having a radius r to be equal to 20 centimeter and an angle 100 degrees, okay? Find that. So now let's start now, step one. So if you go to the steps, what I told you is that you have to first find the length of the radius as well as the angle, okay? So let's go. So from this example, the radius is 20 centimeter. The radius is 20 centimeter. And the angle, which is theta, is equal to 100 what? Degrees. Now step two. Okay, we need to then find the area of the sector. And we know the formula for the area of a sector is theta over 360 times pi r squared. Okay, and that will give us theta is 100 divided by 360 multiplied by pi multiplied by what is the radius? 20 all squared. Then when you're done with that, step three, you just press this into your calculator or you just punch it into the calculator And when you've punched this, your answer should be, I think, 1,000 divided by 9 pi. Okay? This will be centimeters squared. Or if you want it in decimals, it should be 349.07 centimeter what? Squared. Okay? So in this question, it was pretty straightforward. The area when you have the R and the angle. So let's take it a step further now, all right? What about if in a case you'll be given the diagram and you were told to find the area of the sector, all right? So if, for instance, you were told to find the area of the sector shown below, all right? So in some cases, you could be given the diagram and you'll be told to find the area. So let's assume we had something like this, and we have this kind of sector here, okay? And we're told that the angle here is 115 degrees, and we have this to be 18 centimeter. And we're told to solve this. So what do? Step one, the first thing to do is that we need to identify the radius as well as the degrees. So, and the angle, sorry. So the radius here is what? 18. And the angle, which is the theta, is 115 what? Degrees. Then step two, we need to then apply the formula. So step two, we need to apply the formula, and we know that the area of a sector is equal to theta divided by 360 multiplied by pi r squared. Okay, so in this case now, it's so obvious that we know that the theta here was 115 degrees divided by 360 multiplied by the pi multiplied by the radius was 18 all squared. Now, so step three, we then simplify. So you put this into you punch this into your calculator. And when you press that, it should give you 207 divided by 2 pi centimeter what? Squared. Or if you need this in decimal, it should give you 325.15 centimeter what? Squared. Okay? So this is how you solve it. So in this case, so you can see the sector here. Okay, so that means this part here, because if this is the center of the circle, okay, so remember we said this is going to be the radius, so that if it's 18 here as well, it's going to be 18. So it's the radius of the circle. And the angle there is 100 and what? 115. So let's pick another example, one more. Okay, then we'll call it a day for this. So let's assume we have this where we said the sector below, right, has an area of 70 centimeters squared. And we're now told then to calculate the angle theta given the radius is 10 centimeters. The sector below has an area of 70 centimeters squared. So we calculate the angle given the radius is 10 centimeters. So from this question now, you can predict that we have the sector look like this. And we're just told that this part here is just 10 centimeters. and we're told to look for theta. All right. So step one, as usual, we need to identify all the parameters for this question. So step one, all right. The R is equal to 10. The theta, we don't know what that is. Okay, we don't know what that is, so we're looking for that. But we know that the area is equal to what? 70 centimeter squared. Okay, so step two then, we know the area of a sector. Step two, we know the formula for the area of a sector. The area of a sector is equal to theta divided by 360 multiplied by pi r squared. Okay, now, but in this case, we're looking for theta, right? So what we're going to do then, we're going to make theta the subject of formula in this equation. All right, so to get rid of the 360, I'm going to multiply both sides by 360, all right? So this 360 is going to cancel this. So we're going to have 360 multiplied by the area of a sector will be equal to theta multiplied by pi r squared. But we are not looking for pi r squared. We're just looking to make theta the subject of the formula. So I'm going to divide both sides by pi r squared. I'll divide both sides by pi r squared. So this is going to cancel that. Okay. So therefore, theta is going to be 360 times area divided by pi r squared. And then this is going to give us, what is this? 360. What was the area we were told from the question? We were told the area was 70 centimeters squared divided by pi multiplied by, what was the radius in this question? The radius was 10 divided by 10 squared. So this is going to give us the theta. Step three, we then punch it into the calculator to get the answer. And when you punch this into your calculator, the theta is going to be 80.21 degrees. And that will be the answer for that. So you see that the question can come in different forms. Sometimes you might be given the area, you might be asked to find the radius, given a particular theta value, or you can be given the area and the radius, and you're asked to find the angle, or you could be given the angle and the radius, and you can be asked to find the area. So regardless how it comes around, you can play around with it, but the key thing you need to know that the area of a sector is theta over 360 times pi r squared. Then you play around with the rest, okay? And that is that for that with all the questions we've dealt with in this video. The next video, I'm going to go to how to find the area of a circle. All right, how to find the area of a circle. And it's important that you subscribe so that when I post the next video on the area of the circle, you will be the first person to know. All right, so I'll see you soon. What we discuss the area of a circle.